Hello and welcome to my YouTube channel. Today in this video we are going to talk about interrupt based analog to digital conversion using STM32F44 6RE microcontroller board. This is a two-part video, and in the next part I will show you how to implement the code and run the code on STM32 microcontroller board. So let's start the video. So first of all, let us understand the concept of interrupts. So by definition, interrupt is a signal that temporarily halts the normal execution of microcontroller's main program, and it allows the microcontroller to run a small code which is known as interrupt service routine, or also known as ISR, in response to any event. This event can be internal or external. So what is the purpose of using interrupts? So basically, if suppose we have an event like analog to digital conversion or timer or digital to analog converter, so in those kind of events, microprocessor will respond to such events instantaneously, and such events will help the microcontroller to use the resources properly instead of using polling technique, because till now we have been using polling technique for reading the analog to digital converters value. So now the question comes, what is the utility or what is the benefit of using these interrupts? Basically, interrupts improve the efficiency of the overall system because it enables the microcontroller to perform other tasks, and even it allows the microcontroller to enter into low power modes or sleep modes, and whenever any event occurs, those events may wake up the microcontroller, and that will allow the overall system's efficiency improvement in terms of power. Now, what are the types of interrupts which can be used in the microcontroller based systems? Like I said, there can be two types of interrupt. One is hardware interrupts, which are generated by external hardware devices like sensors, buttons or switches, and secondly, software based interrupts, which are generated by the software instructions, which generally are triggered by interrupt service routines. So for example, you have a button, and if you press the button, only at that event the microcontroller will trigger an interrupt and execute a small code which will be written for that particular event. Or we can generate timer based interrupt, where timers will keep on generating interrupts after a particular time or completion of the counts. So such interrupts will also help the system to improve the overall efficiency. Now, let us talk about how the microprocessor handles the interrupts. So basically, we have a term called interrupt request, which is generated by the external hardware or even internal softwares. And whenever interrupt request is generated, microcontroller is indicated that a service has to be completed, and that service is basically the service which is written inside the interrupt service routine, which is basically a small code of or small program. So what are interrupt service routines? Basically, interrupt service routines are special functions or block of codes that execute in response to any interrupt, be it external or internal. So while the ISRs are executed, microcontroller temporarily pauses the main program, saves the state of the main program in the stack, and executes the interrupt service routine, and then after completion it will return back to the main program. For that, microcontroller or microprocessor uses the stack memory. In general, microcontrollers have their own set of interrupts which are called interrupt vector tables. So all the hardware interrupts which are present in the microcontroller have a specific address, and those address are basically used to write the interrupt service routines. So we are not going deep into the concepts. For further details, you can check my playlist. I have talked a lot about interrupt vector table and interrupts even in other microcontrollers. Definitely, when we have multiple interrupts, then we have to have a system by which we can schedule the interrupts based on their priorities. Otherwise, all the interrupts will start using the microcontroller's resources, and which may corrupt the overall system. To avoid that, we generally prioritize the interrupts, and based on the priorities, interrupts are provided the CPU resources. So prioritization ensures that more critical interrupts can preempt less critical interrupts. So higher priority interrupts will preempt or may stop the lower priority interrupts. Now, there may be even multiple interrupts, or we can call them nested interrupts, where an interrupt is generated from an interrupt itself. So in that case, we will call them nested interrupts. Or we can even disable some of the interrupts by using certain features which are present in the microcontrollers, so that if any interrupt occurs through that channel or through that hardware, we can block such interrupts. So this is all about the basic functionalities. Let us try to understand why interrupts are important. For that, we have to understand what is polling technique. Here I have tried to picturize the working of polling technique in a very simple manner. Might be possible there may be some small errors, but this will help you to understand how the polling works and how the interrupt allows the programmer to avoid the deficiencies of polling technique. So basically, a microcontroller contains a base CPU, or we can call it central processing unit. It can have multiple peripherals like ADC, DAC, general purpose input output pins, timers, and so on. Apart from these peripherals, microcontrollers also contain memory in which the main program resides. So when we talk about polling technique, so suppose there is an external sensor which is connected to one of the ADCs of any microcontroller, and the ADC reads the value of the temperature sensor, passes the ADC values to the CPU for further processing, and for that microprocessor or CPU may use the main program, and the main program keeps reading the ADC values, and in this way a feedback loop kind of thing takes place, which is shown here in this way. So this will keep the microprocessor always engaged because it is always reading the ADC according to the main program. So this actually is nothing but wastage of CPU resources, because CPU is always busy in reading the ADC value. Similarly, we may have systems where we may keep on polling other peripherals like DACs, GPIO pins or timers and so on. So basically we can see here that the CPU is always busy. So to avoid this, we are using interrupts. So what happens in interrupt? The same microcontroller, okay, suppose is using the main memory and it is communicating with the main memory with a small program, or we can say main program. So there may be a trade-off or a data transfer between the CPU and the main program or memory. So in such case, suppose any peripheral want to inform the microcontroller that I have some data to be processed. In that case, that particular peripheral, in this case for example ADC, can generate an interrupt to the CPU. And after receiving the interrupt, CPU will take the main program's current state and save them in the stack memory. And then after that, the main program will switch to interrupt service routine. So basically ADC will use the interrupt service routine, and that interrupt service routine will give the data to CPU. And this will take a very small time period, or we can say a very small instance of time, and it will complete its job. And after that, the main program or the CPU can return to the main program. So in this way, whenever any external hardware has to communicate with the CPU, it can generate an interrupt and it can provide the data to the CPU for further processing. And in this way, CPU can get engaged in other jobs also. So suppose DAC want to send some data to CPU, it will send the data to CPU via its interrupt service routine. Similarly, the GPIOs can also provide data to the CPU via their interrupt service routine. And similarly, timers or any other peripherals can provide the data to CPU for processing via their own service routines or interrupt service routines. So in this way, interrupt service routine or interrupts help the microcontroller to save its resources or save the resources of the CPU and complete all the tasks within a specific time period. For this project, we will be using the same connection where we will again use the same temperature sensor, and temperature sensor's analog channel will be connected to A1 line of the microcontroller board. For that, please check the upcoming video. With this, I would like to end the first part of this presentation, and then in the next presentation we will see how to use interrupts and make our system more efficient. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the notifications as soon as I upload a new video. If you have any suggestions or comments, then please share your suggestions and comments in the comment section. Thank you and have a nice day.